In this lesson, we shall focus on financial mathematics, simple interest, compound interest, annuities, future value annuity, present value annuity. We shall solve a wide range of past exam questions, and we shall see how well we fare in solving the past exam questions on finance together. Okay, this is a collection of past exam questions, but I want us to work through these together. Make sure your calculator is available, and also make sure that your scribbler is next to you to try the questions alongside, because I'm interested in seeing what you can do, and then I give you the answer. What I need to see first, what you can do, then I give you the answer. It's not a question of me just giving the answers and then you just see the answers, but you don't understand. So that is what we need to fight against. And moving into this week, we shall be having a lot of lessons this week. Why? Because the prelims are here and we cannot. So 8 o'clock at night, you do your things earlier, but 8 o'clock in the evening, you must join in so that we can discuss and practice together and cover the sections you'll be interested in. So it's very important you communicate the sections you don't know, the kinds of questions. You're like, okay, I don't understand these. We have not done this in school. You let me know so that I can incorporate that in our discussions. That is going to help you to actually become the best you can be. A company bought a photocopier for 150,000 rand on 1 July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time. And that will be on the 30th of June 2027. Right. So the average rate of inflation over the next 5 years will be 6.5% per annum. So they've given you the average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. What do you think? Okay, what formula do we use here to find the price of a new photocopier in 5 years' time? If we're told that the average rate of inflation over the next 5 years will be 6.5% per annum, determine the price of a similar new photocopier in 5 years' time. I'm asking the question, what formula do we use here? Because there's a timeline. The timeline is as follows, which is time 0, time 1, time 2, time 3. And now you are actually given this particular information that the company bought a photocopier for 150,000 on 1 July 2022. In other words, there's time 0, which is 1 July 2022. And at this time 0, there is an amount of money, 150,000. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time. And in 5 years' time, that is going to be exactly 30th of June. And that will be like T60, right? Which will be exactly 30th of June 2027. And this gives us 5 years. However, the average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. I want us to engage than just to give the memos to this, to give you the answers to this. But the question is, if you are given inflation, the average rate of inflation over the next 5 years, how do you find the price of a new commodity? How do you find the price of a similar new photocopier in 5 years' time? What formula do you use if inflation is given? 2 marks. Anyone? What formula do we use? What formula do we use? Tando. What formula do we use? Tando.
The compound formula.
The compound interest formula.
Yes, sir.
Yeah, so we could use the compound interest formula, the appreciation formula. Because now if inflation is given, it means that there is an increase in the costs. So now, which means that you'll have the 150,000. 1 plus, then you have the 6.5% divided by 100. 0.065. You divide the 6.5 by 100, you raise it to the power 5 years. And then let us check the answer. I want us to engage more and discuss more. It's not a question of me just saying this is the way to do it, when somebody, for instance, does not even apply their minds to it. Right, so we actually will do this. I'm trying to get the calculator here. Right, I'm trying to get the calculator just now. Right, let me see if I can be able to get that. Right, let me see if I can be able to get that. It's fine. Anyhow, right, so we are sure, therefore, that if you use a calculator, you'll actually be able to get the following amount: 205,513. Exactly that. Exactly that. 205,513. Okay, and that is the answer. Where's the question? No question. In the absence of a question, we move on to the next question. Right, a company bought, it's the same story, that the company bought a photocopier for 150,000 on 1 July 2022. They will use the old photocopier as trade-in when they replace it with a similar new photocopier in 5 years' time on the 30th of July 2027. Calculate the trade-in value of the old photocopier after 5 years. If it depreciates at a rate of 9% per annum on a straight line method, what formula do we use if we speak about depreciation on a straight line method? What formula do we use?
I say, can I try?
Yes, please.
It's gonna be A equals to P
A equals, yeah?
to P,
Yup.
open bracket 1 minus I
Yes.
over K. Is it over K?
Yes, yes. You can just write it like this. Okay, because now the straight line, the n is not a power. So now, because they're speaking of the straight line method, this is the formula we use. And this formula, because there's a minus, it shows depreciation. And then there's another formula we use at grade 10. These are like grade 10 formulas. This one is appreciation. But you see, it doesn't mean that when these things are done in grade 10, then you cannot find them here. So they bring these things here and they ask you these questions. So calculate the trade-in value of the old photocopier after 5 years if it depreciates at a rate of 9% per annum on a straight line method.
Yeah.
So which means that the trade-in value of the old photocopier, right, now the old photocopier was bought at 150,000. 150,000. Which is 1 minus 0.09 by what? 5 years. Okay, then you take the 9%, you divide by 100, and you get 0.09. You multiply, therefore, by 5. Therefore, upon careful examination, therefore, you attempt to use a calculator to do this, for instance. So what answer then are you able to get if you use a calculator? What answer are you able to get if you use a calculator? Right, if you use a calculator, you'll get exactly 82,000. 82,500. So this would be the trade-in value of the old photocopier after 5 years on a straight line method. The straight line method means it's 1 minus IN. Okay, we're good, I believe. Grade 10 work, but it is coming here to you. It's given to you. This straight line, appreciation, depreciation. Depreciation is the one with the minus, and appreciation means growth in value, and depreciation means reduction in value. Next question. Next question. Right, now the company set up a sinking fund to cover the replacement cost of the new photocopier. So they set up something called a sinking fund. A sinking fund is a savings account. The fund earns interest at the rate of 7.85% per annum, compounded monthly. The company made its first monthly deposit on 31 July 2022, and will continue to do so until 31 May 2027. 1 month prior to the new photocopier being bought. How much should be deposited at the end of each month so that the company will be able to buy the new photocopier? The company made its first monthly deposit on 31 July 2022. Remember that what is happening here, this company bought this photocopier for 150,000 on 1 July 2022. This is the story. What is happening here? There's something we call a timeline. Right, so you're going to use a timeline. With the timeline, we're going to have the following. We're going to have like time 0 in the beginning of all things. Let us put the timeline here. Right, so you're going to have time 0. Time 0, there is 150,000. 150,000 that is sort of used to buy the photocopier. The fund earns interest at a rate of 7.5% compounded monthly. The company made its first monthly deposit. This was on 1 July 2022 when the company bought this photocopier. At time 0, it was exactly 1 July 2022. Okay. Now, the company made its first monthly deposit on 31 July 2022. Time 1. 31 July 2022, then the company made its first monthly deposit. Okay. And this deposit, you don't know how much this deposit was, so we're going to call it X. So the company made its first monthly deposit on 31 July 2022. Because July starts here times 0. 1 July 2022 and 150,000 is there. And then now the time is allowed to go, and this will continue until 31 July 2027. Until, yeah. So now you know that the first monthly deposit was on 31 July 2022. So you have 31 July, then there is a monthly deposit there. But you don't know how much that was, and will continue to do so until 31 May 2027. Because remember, the new photocopier will be replaced in 5 years' time on 30th of June 2027. But now this is going to go on until 31 May 2027. Now, but now in 5 years' time, that's going to be exactly T60, because 5 years. N equals 5 years multiplied by what? Multiplied by 12 months, and therefore it is 60. 60 months. So 5 years are equal to 60 months. So that we're going to have times 60 on this timeline. The company made its first monthly deposit on 31 July 2022 and will continue to do so until 31 May 2027. 1 month prior to the new photocopier being bought. So they've paid up to here 1 month prior to the photocopier being bought, because the photocopier is going to be bought on the 30th of June 2027. 30th of June 2027, then the photocopier is being bought. But the payments are going to run up to this. So there's going to be time 2, then there's a payment. Time 3, then there's a payment. And these payments go on. How much should be deposited at the end of each month so that the company will be able to buy the new photocopier? Okay, this is sort of the story put on the timeline here. Right, so first things first, we need to take into account the fact that there's something we call the sinking fund. How much is the sinking fund? The formula for the sinking fund states that the sinking fund is equal to the final amount minus the trading value. So now, we know very well that subject to inflation, a new photocopier will cost 205,513. Then you have the trading. When they trade in the old one, when they sell the old one, how much are they going to get? They're going to get the depreciation we got before, and the depreciation we got before became exactly what? Depreciation we got before was 82,500. In other words, the trading value was 82,500, and we plug it in here. We plug it in here. So it is exactly 82,500. You subtract these two things, and you get exactly 123,013. 123,013. Now let's look at this. So now which is exactly X. Okay. Which is exactly X. 1 plus I to the nth power. Okay, this becomes a future value annuity formula. Future value annuity formula. F for the future value is X open bracket 1 plus I to the nth power minus 1 divided by I. But we note that this one here, there is a missed payment. There is a missed payment. So if there is a missed payment, right, what do we do? Because they stopped here and they stopped 1 month prior to the new photocopier being bought. And the new photocopier is going to be bought in 5 years' time, 60 months. On the 30th of June 2027, they're going to buy a new photocopier. It means, therefore, we're going to have that the future value is 1 minus that. The future value becomes P, becomes the present value, so that you put an extra factor to accommodate the fact that you need to provide compound interest. Compound interest for a jump here for the missed payment. Okay, so let us substitute everything up at this point. What is the future value? 1, 2, 3. X. Okay, now what is this one? Divide this to 7,85 by 100. It becomes exactly 0, 0. 785 divided by what? Divided by 12. All raised to the number of the payments, because now these are supposed to be T1, T2 up to T60, but they stopped just 1 month before. So which means that if they stopped at 60 minus 1, they stopped at 59. So you're going to put a 59 here. Right, so you're going to put exactly a 59 here. Right, so 59 minus 1 divided by 0,0785 divided by 12. 1 plus 0,0785 divided by 12. All to the power. Now here it provides 1 month. It was exactly 1 month prior to the new photocopier being bought. Now the new photocopier is going to be bought in 5 years' time. It's going to be replaced in 5 years' time. So it was 1 month here, and then we're going to put 1 like this. Right, it remains for us to solve for X. So we have exactly 1, 2, 3, 0, 1, 3 equals X. 1 plus 0,0785. You divide by 12 to the power 59 minus 1. 0,0785 divided by 12. One plus 0,0785 divided by 12. And then 1 month. And then we need to solve for X. So which means therefore at this point we can make X the subject. 1, 2, 3, 0, 1, 3 multiplied by, we cross multiply. 0,0785 out of 12. You divide everything by, because you cross multiply then divide by these things. 1 plus 0,0785, you divide by 12 to the power 59 minus 1, and you multiply by 1 plus 0,0785 divided by 12 to the first power. If you use a calculator, then this is approximately, use the calculator, it's approximately 1704. 1704,01. Any question? Okay, some of these questions will require more reasoning, but in this question, you need to remember that the formula for the sinking fund is actually the future value minus the final amount minus the trading value. That becomes the sinking fund. And that is what we use to get the sinking fund. And now the A is actually obtained from the compound interest appreciation formula. And we get the A, and then the trading value is actually how much the photocopier will be worth at the time that it's sold. So when you sell it, you trade it in, they give you some money because you are actually replacing the equipment. Okay, now let us continue and look at the next question. I need your participation in the next question. It's not a question of you just watching. Today, Andrew borrowed 200,000 rand from a bank. The bank charges interest at 5.25% per annum compounded quarterly. Andrew will make payments of 6,000 at the end of every 3 months. His first payment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? Yep. We read again. This question you need to read like 2 times, 3 times to make sure you understand. Normally, you can't just read once because you'll make a mistake. You'll think you understand the story when you don't. Right, because we read again for the second time. Today, Andrew borrowed 200,000 rand from a bank. The bank charges interest at 5.25% per annum, compounded quarterly. Andrew will make repayments of 6,000 at the end of every 3 months. His first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? We read once more, that time. Today, Andrew borrowed 200,000 rand from a bank. The bank charges interest at 5.25% per annum, but this is compounded quarterly. Andrew will make repayments of 6,000 rand at the end of every 3 months. His first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? Very simple question. What formula do we use here, Nombuso?
Say.
What formula do we use here?
The present value.
Present value formula. So the present value formula, well done. So it is x1 minus 1 plus I to the power minus n divided by I. So what is the present value here, Nombuso? 200,000. Okay, never mind. Okay, that's fine.
Sorry,
Thank you so much. Okay, so the present value is 200,000. Right. And what is X? How much are the repayments? Repayments of how much? Repayments of 6,000. Right. So you put 6,000 for the repayments. Then you have 1 minus 1 plus. Then you take the percentage of 5.25%, but you divide by 100, which is 0.0525. You divide by what? It's compounded quarterly, so you divide by 4. And you raise it to the power minus 4n, all divided by 0.0525 divided by 4. Okay, so which is 0.0525. You cross multiply, you divide by 4, like this. And you also, after cross multiplying, you divide by 6,000. And this is 1 minus, okay, 1 plus 0.0525 divided by 4 to the minus 4n. Okay, if you do the calculation here, you realize that this is exactly the same as 7 out of 16. 1 minus 1 minus 1 plus 0.0525 divided by 4 to the minus 4n. Okay, so that now we have 9 out of 16. Okay, if you subtract 1 from this, 7 out of 16 minus 1, you get or you can take this one to the other side and then say 1 minus that, 1 minus 7 out of 16, you get 9 out of 16, which is actually, if you do this on a calculator, you get actually 1621 divided by 1600, all to the power minus 4n. And this means that minus 4n is equal to the log of 9 out of 16 divided by the log 1621 divided by 1600. Like this. And if you use the calculator, you'll get, if you divide these things, you get minus 44, 1243. 1243, and then if you divide by negative 4, you'll get actually 11,03 years. You're asking the question, his first repayment will be made in 3 months from now. How long in years will it take Andrew to settle the loan? Now, the couple of things you need to take into account here, that it is compounded quarterly, meaning it's compounded every 3 months. A quarter is every 3 months. But the first repayment is also made 3 months from now. Now, what is happening here is the following story. So there's time 0, time 1, time 2, time 3. Now, Andrew borrowed 200,000. Present value. The bank charges interest at 5.25% per annum, compounded quarterly. So this interest is charged every quarter, every 3 months. But Andrew will make the repayment of 6,000 at the end of every 3 months. So now there's 3 months that it's starting and then it's ending, and then at the end, then he pays 6,000. Then another set of 3 months starts and ends, and then he pays another 6,000, and so on and so forth. And this goes on. Look, if you have times 60, and then you have 60,000, which is exactly, rather 6,000. So this is exactly what we have. So the question then becomes, this is 3 months. And as you said, that because it is 3 months, 3 months, 3 months, 3 months, 3 months, 3 months, 3 months everywhere, this present value formula, and obviously if in the compounding period is 5.25 5.25% per annum, but it's also compounded monthly. Per annum compounded quarterly, compounded quarterly. Now, okay, I mean, this is the timeline, right? But obviously, if it's 3 months, 3 months, then this is the formula we use, and this is the present value. It is a loan. This is the formula we use for loans, because loans are those amounts of money that are borrowed from the banks. Somebody borrows money from the bank and they want to use it. They want to buy shoes. They go to the bank and they borrow some money and the bank lends them the money. We move on to the next question. Patrick, I need your participation here. Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was 19,319 Rand and 48 cents. Calculate the value of R. Calculate the value of R. Who can find the value of R? What formula do we use to find the value of R? What formula do we use to find the value of R? Who knows?
We use the compound formula.
Well done. Thank you so much, Tando. Compound interest. Thanks so much, Tando. 1 plus I to the nth power. So now we take note of the following. That Patrick deposited an amount, so there was a present value of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was this. So this became our A, and this was our present value. So the final amount became exactly 19,319,48. Present value 18,500. 1 plus. What is the interest rate? It's R%. So it's R%, then you divide by 100, but it's compounded monthly. You divide by 100 and then you multiply by 12 like this, in the denominator. And now after 6 months, his balance was this, which is exactly 6 months there. In the end, what you do, you take the 19,319 Rand and 48 cents, you divide by 18,500, and this is 1 plus R divided by 1,200. You raise it to the 6th power, like this. In which case, therefore, you apply the 6th root both sides. The 6th root of 19,319,48, you divide by 18,500, which is exactly 1 plus R over 1,200, 6th power. Right, so if this cancels out, you have this one. 19,319,48 divided by 18,500, 1 plus R over 1,200. You have the R, which is 1,200. The 6th root, 319,48 to divide by 18,500 minus 1. And then now you'll be able to get the answer. Okay, and then now if we have the R, if you use a calculator here, you'll be able to see that R is approximately 8.7%. R is approximately 8.7%. R is approximately 8.7%. So now we have found the value of R by using the compound interest formula. We used the what? We used the compound interest. Compound interest formula. That's what we have used. We move on to the next question. In the next question, is as follows in 6.1.2. Calculate the effective interest rate. 2 marks. What formula do we use for the effective interest rate? What formula do we use? Anyone? Effective interest rate. What formula do we use for the effective interest rate? Who knows? Effective interest rate. Who can find the effective interest rate? What formula do we use for the effective interest rate? Nombuso. Effective interest rate. We need to calculate the effective interest rate. What formula do we use? Nombuso. Nombuso. What formula do we use here, Nombuso, for the effective interest rate? Right. Nombuso, what formula do we use here? Tando, what formula do we use here? What formula do we use here? Tando.
I think the simple interest.
Okay, that's fine. There's a formula for effective interest. Please learn it. It's actually 1 plus I is equal to 1. So it's 1 plus I effective, which is 1 plus I nominal divided by M to the power M. Okay, so this is the effective interest rate. And then this one, the I norm means the nominal interest rate. Nominal interest rate. So now we want to calculate the effective interest rate. And so to calculate the effective interest rate, we proceed as follows. Right, so there are a couple of things we already know out of this. You already know the value of R, and we got R here to be actually 8.7%, which is the interest rate, R percent interest per annum compounded monthly. 1 plus I effective. 8.7. Raised to the power. Okay, because now it's compounded monthly, you divide by 12, but you also raise it to the power 12 M, because it's 12 months in a year. And we want to compute the effective rate, so which means therefore you write 1 I effective is 1 plus 8.7 divided by 1200 raised to the power 12 minus 1. Right, in which case, therefore, this becomes the effective rate. If you use a calculator, you get actually 9.06%. And this is the effective interest rate. Effective interest rate. You must learn the formula. And the way you learn it, you must write it down in your book so that you know always that each time you are dealing with effective interest rate, you will learn that 1 plus I effective is 1 plus I nominal divided by M to the power M. This is the formula you use to convert from the effective interest rate to the nominal interest rate. continue. Kuda bought a laptop for 10,000 Rand on 31 January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. The value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0 Rand? The straight line method of depreciation, what is the formula there, Tando? Straight line depreciation method, what is the formula for the straight line depreciation?
So we used the simple instance.
Yes, we use the simple interest formula. That's okay. So we use A equals P1 minus IN. So that now, because now after how many years will the laptop have a value of 0 Rand? 0. The laptop was initially bought at what? At 10,000. The 20% divided by 100, you get 0.2. And you get this. So now you want to solve here. To solve here, you divide by 10,000. So you'd have 0 divided by 10,000. And this is actually 10,000. 1 minus 0.2, and you divide also by 10,000. Which means that 0 is 1 minus 0.2 n. 0.2 n, you bring it across, it equals 1. And it's 1 divided by 0.2. Right, if you divide the 1 by 0.2, what you're getting is actually exactly 5. After how many years? So this is going to be exactly 5 years. It's exactly after 5 years that the laptop will have a value of 0 Rand. So we use the simple interest depreciation formula. The simple interest has two formulae, where A is also P1 plus IN. This is also the formula we use for the simple interest there. We move forward. We move forward. Kuda will buy a laptop that costs 20,000 in order to cover the cost price. He made his first monthly deposit into a savings account on the 28th of February 2019. He will make his 60th monthly deposit on 31 January 2024. The savings account pays interest at 8.7% per annum, compounded monthly. Calculate Kuda's monthly deposit into this account. We proceed as follows. Okay, now Kuda will buy this laptop that costs 20,000. But you note that there are a couple of things that are imperative here. So there is a future value formula where F equals X 1 plus I to the n. This is called the future value. It's called the future value annuity formula. Future value annuity formula. -1. You divide everything by the interest rate I, like so. We plug in everything. $20,000. X. 8,7. 1,200. Okay, now remember that you will make his 60th monthly deposit on the 31st of January 2024. So there's going to be a 60th. So there's going to be 60 deposits, yeah? -1, and you divide by the interest rate. Okay, let me write the whole thing here. So that it can be very clear. So you'd have, therefore, that you have here the 20,000, which is X, open bracket, 1 plus 8,7. The 8,7 is a percentage, so you divide it by 100. Simultaneously, you also divide it by 12. It becomes exactly 8,7. But yeah, you divide by 100, also 12. Raising it to the power 60. And then you subtract 1. You divide every single bit of thing by 8,7. You divide every single bit of thing by 8,7. By, then you put 1,200 here, like so. And then now we want to get the answer to this, and we solve for X. And upon cross multiplication, we would have the 20,000 times that, which is exactly 20,000. You multiply it by 8,7, but you divide by 1,200. All divided by this. Okay, so divide by what is within the parentheses. In this case, it's going to become 1 plus 8,7%. You divide everything by 1,200. Raised to the power 60 minus 1. Right, use a calculator to do this one, and the calculator is going to give you X. It's approximately 267 rand and 26 cents, like this. Okay, we continue. We continue. 267 rand and 26 cents. And this is the answer. We move to the next question. Right, we move to the next question. Right, moving to the next question. The next question is about Tino. Tino. Right, Tino wins a jackpot of 1.6 million. 1,600,000. That is the jackpot that Tino wins. He invests all of his winnings in a fund that earns interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from his fund or from this fund? In this case, the couple of things you need to take into account. Tino is dealing with a present value situation. So the present value is X, open bracket. The formula for the present value is P, which equals X, which is 1 minus one plus divided by I. The jackpot is 1.6 million. 1,600,000. Now, invest all of his winnings in a fund that earns interest of 11.2% per annum compounded monthly, but he withdraws 20,000. So these are sort of the withdrawals. 20,000. 1 minus 1 plus. The interest rate is actually 11.2% per annum, but it's compounded monthly, which is, you can divide this 11.2 by 100, giving us 0.112. Divide by, because it's compounded monthly, divide by 12. Raised to the minus n. You divide by 0.112 divided by 12. Right, so yeah, you get exactly this. Right, sometimes if you divide by 12, you can also multiply by, you can decide not to multiply. It's okay. And then now when you cross multiply these things, what exactly are you able to get? 1.6 million. 0.112 divided by 12. Divided by 20,000. 1 minus 1 plus 0.112 divided by 12 to the power minus n. Meaning that one plus 0.112 divided by 12 to the minus n. Right, so we move this one to the left and this one to the right. Okay, yar. But before you do that, you realize that all these things, if you use a calculator for all these here, the 1.6 million times 0.112 divided by 12 or divided by 20,000 is going to become exactly 56 divided by 75. Okay, if you're using a calculator. And this is 1 minus 1 plus 0.112 divided by 12 to the minus n. If you bring this and you bring this one to the left and this one to the right, is actually exactly 19 divided by 75. Which means minus n is equal to the log. 19 divided by 75 base 1 plus 0.112 divided by 12. Okay, you solve for n here, you use the log. So the base of this particular power becomes the base of the log. Solving for n, you can divide through by negative, but what we're getting here is that minus n. Right, what we're getting here is therefore that minus n is exactly equal to minus 147,80. Okay, if you do the log of this on a calculator, you get minus 147,80. Tino. The conclusion is therefore that Tino will make 147 withdrawals. 147 withdrawals of 20,000. 147 withdrawals of 20,000. Right, so we are sure, therefore, that Tino will make exactly 147 withdrawals. Right, and the reason for that is simply because we know, we can write here a little bit. I mean, if you divide both left and right or multiply both sides by -1, would have exactly a positive end value. So now Tino will make right. So Tino will make 147 withdrawals. Will make 147 withdrawals of 20,000. Tino will make 147 withdrawals of 20,000. On winning the jackpot was like a loan because it was a present value situation, and loans are present values. So now it was like obviously a present value situation, because when Tino won the jackpot of 1.6 million, we are sure therefore that Tino received the payout of 1.6 million, and Tino decided to withdraw 20,000 from the fund Tino had set up. The withdrawals, therefore, are like the repayments of a loan. And now, if you use the fact that this is compounded monthly, you divide by 12 and you raise it to the minus n, and we're able to find n by looking at the exponential equation, converting it to a log equation, and getting minus n equals minus 147,80. Therefore, n equals 147,80. Tino will make 147 withdrawals of 20,000. This lesson is recorded for control and quality purposes. Everything we did today, I will send you tonight. I will send you the recording tonight so that you can watch this and try to make sense of the finance. The best way to learn through this discussion is to make sure that you have pen and paper, you try these things. If you watch the solution and then you think you understand, pause the video, stop the video, try to do the question on your own. See if you can be able to do it. If you can't do it, watch the video and make sure you understand, and so on and so forth. Right, now here's another question. 12,000 Rand was invested in a fund that paid interest at M% per annum compounded quarterly. After 24 months, the value of the investment was 13,459 Rand. Determine the value of M. What is the formula here? What formula do we use here? Nombuso, what formula do we use here? Okay. Maybe I lost Nombuso. All right, I think Nombuso is back, but he's saying the network is not the best. Okay, but obviously, yeah, the network might use. You see, the network, obviously, it happens. It's the network, and it's like sometimes it's there, sometimes it's not there. Okay, right. So if you're looking at the fact that 12,000 Rand was invested in a fund that paid interest of at M% per annum compounded monthly. After 24 months, the value of the investment was 13,459 Rand. Determine the value of M. Determine the value of M. What formula do we use here? Anyone? Anyone? Tando or Nombuso? Anyone? What formula do we use for investments that are compounded quarterly? What formula do we use?
The compound.
Compound interest. Thank you so much, Tando. Okay, I'm teasing you and I'm testing you. So it's we use the A equals P open bracket 1 plus I to the nth power. Be that as it may, 12,000 was invested in a fund that paid interest of M% per annum compounded quarterly. After 12 months, the value of the investment was the value of the investment was 13,000 that much. It was exactly 13,459. The present value that was borrowed or that was invested was 12,000. 12,000 was invested, 1 plus the interest rate would therefore be M because it is M, but your percent, you divide by 100 is compounded quarterly, which means that is 400. Okay, after 24 months, but it's compounded quarterly. So now, if it's compounded quarterly, it means 24 months is like 2 years. Quarterly is by 4, which is 8. Which is going to be 8 quarters. It's going to be exactly 8 quarters. So right here you put 8. Like that. And you want to solve for M. We'll take the 13,459, you divide by 12, which is 1 plus M divided by 400 to the 8th power. The 8th root of 13,459, which is 1 plus M over 400. M, therefore, which is 13,459. 12,000 minus 1, and then you multiply it by 400. Multiply it by 400. So M is 400. If you do everything here, you're getting M is approximately M is approximately 5.78%. M is approximately 5.78%. So at this point, the value of M is 5.78%. We use the compound interest formula because it was an investment, but it was M% per annum compounded monthly. So which means therefore we put M divided by 100, but because it's quarterly, then you also divide by 4. Also divide by 4. All right. So we continue. We continue. Next question. Right, on 31 January 2022, Tino deposited 1,000 Rand in an account that paid interest at 7.5% per annum compounded monthly. He continued depositing 1,000 Rand on the last day of every month. He will make the last deposit on 31 December 2022. Will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that costs 13,000 Rand? Justify your answer by means of an appropriate calculation. Okay, it's a long story, so we need to read for the second time to make sure we understand. On 31 January 2022, Tino deposited 1,000 Rand in an account that paid interest at 7.5% per annum compounded quarterly. He continued depositing 1,000 Rand on the last day of every month. He will make the last deposit on 31 December 2022. Will Tino have sufficient funds in the account on 1 January 2023 to buy the computer? So anyhow, the computer would actually then cost 13,000. But now look, the future value. One plus I. So now then the deposit is 1,000. 1 plus. Okay, we have the 7.5% divided by 100. 0.075 divided by 12. Okay, compounded monthly. He continued depositing 1,000 rand on the last day of every month. He will make the last deposit on 31 December 2022. Remember, now you'll make the last deposit on 31 December 2022, but on 31 January, Tino deposited 1,000. He continued depositing 1,000 on the last day of every month, and he'll make his the last deposit on 31 December. And now it's 2022, so from January to December, it's 12 months. From January to December of 2022 is 12 months. So it's 12 payments. Every month, 1,000, 1,000, 1,000. So N is 12. And therefore now you minus 1. You divide by the interest rate, which is 7.5%, divide by 100, getting 0, that, divided by 12. The future value is approximately 12. 421, 22. So now, okay, so this is the future value. So now, but now, if he's paying 1,000 every month, and the interest rate is actually 7.5%, he's gonna have, by the time he makes his last deposit on 31 December, he's gonna have exactly 12,000 in that. 12,421 rand and 22 cents. But look, there is a story that is very important. He wants to have 13,000, but by paying that 1,000 every month, he's just going to have 12,000 in the 12 months. So he's not going to have the 13,000. Remember, Tino, the question is, will Tino have sufficient funds in the account on 1 January 2023 to buy a computer that costs 13,000 rand? So obviously not. So he won't. Right. So we know that he won't. He will not. You will not have enough money. You want to have 13,000, but with the 1,000 every month, he's just going to have 12,000 and some interest. So it means that he won't. He won't be able to buy the computer. He won't be able to buy the computer because 13,000, right? 13,000 minus, you can subtract 12,000. Is actually exactly 578 rand and 78 cents. So it's going to be 578 rand and 78 cents short. You will need like 500 rand and 78 or 578 rand and 78 cents to be in a position to have the 13,000. So his money is going to be short because he wants to have 13,000. The computer costs 13,000, but he has only 12,421 rand and 22 cents. So we can see that Tino is not going to have enough money to buy the computer. Move on to the next question. Move on to the next question. Tabo plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. Calculate the value of the loan. What formula do we use to find the value of the loan? What formula do we use to find the value of the loan? Let's read again. Tabo plans to buy a car that costs 250,000 rand. He will pay a deposit of 15% and take out a loan for the balance. That interest on the loan is 13% per annum, compounded monthly. Calculate the value of the loan. Calculate the value of the loan. What formula would you use to calculate the value of the loan? What is the value of the loan? Anyone? Either Tando or Nombuso. 1 mark. 1 mark in the exam. These are past exam questions. They're not from me. I'm trying to make sure that at least on the finance part of things, you're okay. During the week, chemistry and physics, we must make sure that you're okay. On top of chemistry and physics, we must make sure that you're okay on the other things also. Like paper 2, geometry, similarity and proportionality, riders and questions that combine a lot of the theorems in geometry paper 2. You must be comfortable with those. But for that, we shall actually devote a lot of time this week. We shall devote a lot of time this week, and I'm going to be posting more appointments on the WhatsApp groups. But if you read this question, Tabo plans to buy a car.
Okay.
Yes, please, Tando, what do you think? What is the value of the loan?
I got 212,500.
Okay. Well done. Well done. How did you get it, Tando? That's correct.
Okay. He said he will pay a deposit of 15%.
Yes.
15% of 260,000 is 37,500.
Yeah.
So I subtracted 37,500 from 250,000.
Okay. So 250,000. And then you remove 15%.
Yes, sir.
Yeah, you remove 15%. Well done. That's correct. You remove 15% of the 250,000. And when you do that, you'll actually be having the loan amount. The loan amount will therefore become what? It will become, if you use the calculator, you'll get actually 212. You'll get actually 212,500. Because now there is a, he will pay a deposit of 15%. So we're gonna minus 15% of the 250,000. And if you minus 15% of the 250,000, you'll get 212,500. Correct. Okay, that is the loan amount. So if we know that the loan amount here the loan amount is 212,500. The first payment will be made 6 months after the loan has been granted. The first payment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly, the examiner even put some bold letters there, monthly installment. They put some capital letters, for the word monthly. Okay, now let us look at this question together. I would need your maximum attention here because this is very, very important for you. Now, what is happening here? Because let us reason together. This is a tricky question. The marks are 5 allocated for this. So there's a little small trick, but very small. Now, you have to look at the fact that time 0, time 1, time 2, time 3, time 4, and so on. The first repayment will be made 6 months after the loan has been granted. So there's T5, there's T6, like 6 months. If we are doing everything because it's compounded monthly. So we're moving in months, because compounded monthly means that every period here is a month. Now, and this goes on like this, but this is for 6 years. So now what will 6 years yield? How many months will those be in the 6 years? Okay, so you take the n equals 6 years times 12, which is 60 plus 12, 72. 72 months. So you deal with a total of like T72 months, okay? Because you're dealing with 6 years altogether, every month. But the first payment will be made 6 months after the loan has been granted. Right, the loan was granted here. And we understand that the actual balance on the loan is exactly what? The loan amount is 22,500, 212,500. That is the loan, present value, right? It's there in the beginning. The first payment will be made 6 months after the loan is granted. So 1, 2, 3, 4, 5, 6. Then the first payment is going to be made. And then the loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. So you're dealing with 6 years. Right. But now, because this is called a deferred, it is called a deferred annuity. Deferred annuity. Right. So now, if this is made 6 months after, so you have to move this one and put it here just 1 month before, so that you have 1 month, 1 month, 1 month, 1 month, 1 month. The present value formula for the loans is 1 minus 1 plus I to the minus n divided by I. You take the 212,500. 1 plus. Right, so you actually consider the fact that it's 13%. 13% is 0.13, but it's compounded monthly, divide by 12. And now you must move it 5 months forwards. 5 months forward. So the P now is going to be mixed up and combined with the compound interest. X, which is 1 minus 1 plus 0.13 divided by 12 raised to the power. So you take the 72, you minus 5, like that. And so when you minus, you get exactly, you minus the 5 months where there were no payments. So if you subtract these things now, you have 72 minus 5, and you're getting 67. Okay, some of these are a little bit tricky. But I'm expecting Nombuso to actually master this because Nombuso is big already to master these things. At least Tando is still growing. Okay, so now you have 0.13, you divide this by 12. Right, after this, then we actually continue to solve this, and we need to be able to solve for x. So which means that you'd have 212,500. And then you have 1 plus. Okay, divide by that. Raised to the 5th power is actually exactly equal to x. 1 minus 1 plus 0.13 divided by 12, then it is raised to minus 67. You divide by 0.13, divide by 12, like so. Upon careful examination, we cross multiply 212,500. 1 plus 0.13 out of 12 to the 5th power, you cross multiply and you have 0.13, you divide by 12. Okay, yeah, so you cross multiply and then you divide by this. 1 minus 1 plus 0.13 divided by 12 to the power minus 67. And this is exactly x. Right, upon careful examination, you are able to see, therefore, that x is equal to 4,724,96. So that then in the end, it's 4,724 Rand and 96 cents. Right. So this is the actual value, because calculate the monthly installment. So the monthly installment using calculator for all these, it's going to be exactly 4,724 Rand and 96 cents. So you need to think about this. But we proceed to the next question. Right. So how many years will it take for an investment to double in value? So the investment doubles in value if it earns interest at a rate of 8.5% per annum compounded quarterly. How many years will it take for the investment to double? What do you think? What formula are going to use here? Nombuso. What formula are going to use here? Nombuso. If Nombuso is still here. Maybe Yar. Maybe the network is bad. Nombuso. How many years will it take for the investment to double in value if it earns interest at a rate of 8.5% per annum compounded quarterly? Nombuso.
Sir.
Yes. What do you think about this question? Are you able to see the question? Let's read together. How
Yes,
many
sir.
years? Okay, how many years will it take? How many years will it take for an investment to double in value if it earns interest at a rate of 8.5% per annum compounded quarterly? What formula do we use here, Nombuso, for the investment that is going to double? What formula do we use to solve this problem? What formula? I'm just testing you.
I think, yes, sir. I think we gonna use the formula of yeah, how do you call this? Yeah. Yeah, if okay, interest effective, it's effective, say.
Okay, that's fine. That's fine. That is the formula for the effective interest, compound interest, effective interest. It's okay. This is recorded even if your network is bad, but you're going to receive the recording today. You're going to receive the recording today so that you can listen to this in case your network is bad. So you'd have 1 plus I to the nth power, right? So then we continue. If you look at this, which means that the investment was initially P, and if it doubles, it becomes 2P, P1 plus. The percentage is 8.5%. You divide by 100, it becomes 0.085. You divide by 4 because it's compounded quarterly. Raised to the power 4. Divide by P both sides so that we have 2 is 1 plus 0.085. You divide by 4, but it's also raised to 4n. So that in the end, then we have 4n is equal to the log. It's actually the log of 2 base 1 plus 0.085 divided by 4. Okay, now if this is the case, then you can solve for n, and that is what you get. And now we want to solve for n, and to solve for n, please, you're going to receive this recording even if your network is bad. You divide by 4, actually giving us 1/4. The log of 2 base 1 plus 0.085, you divide by 4, meaning the interest rate, or rather the period n in years, using a calculator gives us 8.24 years. So that it would take 8.24 years for the investment, to do what? To double in value. If the investment doubles in value, you start with an investment P, and the investment becomes 2P because it then doubles in value. It then doubles in value. It doubles in value. It doubles in value. So now you divide by P and you get the answer here. Right, so this is something you need to think about. It's something you need to know. Let us look at the next question. A company purchased machinery for 500,000 Rand. After 5 years, the machinery was sold for 180,000 Rand. A new machinery was bought. Calculate the rate of depreciation of the old machinery after 5 years on the reducing balance method. What formula do we use for the reducing balance method? Tando. What formula do we use for the reducing balance method? What do you mean by the reducing balance method? What formula is that? Tando. The reducing balance method. If they say reducing balance method, what formula do we use here? Tando. Nombuso. Reducing balance method. What does reducing balance method mean? What formula do we use in case they say reducing balance method? What formula do we use, Nombuso?
Say
Yes.
The formula that we use is the compound interest.
Compound interest. Yes, so reducing balance method, we use compound interest with a minus. Compound interest with a minus. All right. Remember that the company purchased machinery for 500,000. After 5 years, the machinery was sold for 180,000. So there was a present value of 500,000, but it was sold for 180,000. Right. And then have 1 minus I to the power 5 after 5 years. And therefore now you divide 180,000 by 500,000, which is 1 minus I to the 5th power. 9 out of that, which is 1 minus I to the 5th power. Okay, so 180,000 divided by 500,000 is 9 out of 25. And then now this would actually exactly be the 5th root. So you take the 5th root on the left, but also you take the 5th root on the other side of 1 minus I to the 5th power. Right, so this is 1 minus I, the 5th root of 9 out of 25. All right, so we want to solve for the rate of depreciation. I know that tomorrow you guys are going to school, so I must think for you. Right, so that then the rate of depreciation, we want to actually be in a position to solve for I. So we move this I to the left, and then we have 1 minus the 5th root, 9 out of 25. And this is approximately 0,18480, 0,1848068, which is approximately 18,48%. So then the rate of depreciation is actually 18,48%. I believe that you can see the rate of depreciation formula, but also the reducing balance method is the A equals P open bracket 1 minus I to the nth power. This is called the reducing balance method. It's already there in the trial exams, guys, for you in the September term 3 tests and so on. It's there. For you, Nombuso, it is there in the prelims on the 30th of August. Please, 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 you need to learn it. Right, it's just after 10 o'clock tonight. We must thank you guys for joining us. It was awesome having this discussion. I'm going to post this video. I'm going to make it available for you to watch. Right, it was awesome. Maybe I can give you homework. Here is the homework. Your homework is that a company purchased machinery for 500,000. After 5 years, the machinery was sold for 180,000 and new machinery was bought. The rate of inflation for the cost of the new machinery is 6.3% per annum over the 5 years. What will the new machinery cost at the end of 5 years? So this is your home activity. It 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 is your home activity. So this is your home activity. Guys, I must thank you for joining us. Any question? No question, Tando. No question, Nombuso. Right. I will see you guys during the week. During the week, I'm going to be posting on the group. We're going to be doing more mathematics and more chemistry and more physics. Please. So it's very important that you pay attention to the WhatsApp group, because I'm going to be posting in the morning hours so that you can know that there's a class later on in the evening, so that you can prepare yourself for the class there. But yeah, there are going to be more classes this week during the week at 8 o'clock at night. I'm looking at the fact that you have the whole day to do your own things, and then by 8 o'clock you are free, and then you can join the class. Right. It was awesome having a discussion. There's your home activity. You need to try it. And until next time during the week, take care and good night. Right. Good night. Good night.